everyone and welcome to my new class, and today our chapter is polymer. This is the polymer part 5th. Yes, a part 5th of the polymer, meaning this is the last part of the polymer chapter. We're going to cover about natural rubbers, artificial rubbers, as well as about the structures about neoprene and isoprene and so on, and also about biodegradable polymers, talking about PHBV and Nylon-2 Nylon-6. We're going to talk about our chapter and be able to get 3 out of 3 for our lesson. Let's talk about my part 1, part 2, part 3 and part 4. If you haven't watched the video, my humble request to all of you, please to watch the video. I have worked very hard to make those content, good content for you, so you can learn from it and take the maximum, maximum benefit from it. So please to watch the video. So question comes with us, natural rubber. There's only one natural rubber which I have learned, and natural rubber monomer is Isoprene, Prene, or should I say another name for it would be 2-methyl buta 1,3 diene. Okay, correct. So common name might seem complex to you, if not complex, difficult for you to interpret the structure of the natural rubber, but I basically can help you out. Yeah, so this is your should I say the prefix, but let's talk about this main part. It says it has buta is 4 carbon, so you have 1 2 3 4 carbon. Okay, then it says at first and third position it has double bond, so first position double bond, third position double bond, because 1 2 3, yeah, other will be single bond. Then it says that it is having 2 methyls, and second position is having methyl CH3. Okay, now when I add up the H required, then I get a structure like this. Find n times. So this is my isoprene. Basically this is my isoprene. Now this one, after polymerization, what I'm gonna get. But how would the polymerization occur? You know it. There's gonna be a shifting of the bonds. So from here, one bond will go here, one bond will go here to give me proper structure. So let me say there are 2 isoprene like this monomer combining together. Then how would the structure look like? So let's see. It's gonna look like this way: CH2, C, CH3, double bond, CH, single bond, CH2. One more time is happening: CH2, C, CH3, single bond, not single, double bond, CH and CH2, and continues. Okay, now this is how it looks like, quite long, interesting. To organize this, we normally write in the cis form. Okay, and let's see the cis form. See, if you don't know what is cis and trans, which you have learned in 11th, we have forgotten immediately what it means. See, let's say trans is like this one. You have the carbon double bond carbon, so they both are same. Let's say XX, and let's say this same. Let's say YY. This is my trans. They kind of like same, and they can easily cancel out because this opposite to each other, to giving me null or 0. Okay, but cis is different. Cis is like this way. Same thing if you have, I'm going to write cis as double bond, X, X, Y, Y. So there's no way to cancel this, how the cis would look like. So you're going to write down the same thing in the cis form now, okay, not in the trans form. And that's what is it. But now why to write it down in cis or trans form? Write it in cis form to make it more organized, and that's the way it is written. So let's see how it's been done. So after this, we can put one more arrow down, arrow up, depending on how a notebook looks like, and mention in the arrow in cis form, CIS cis forms. That's okay. To give me now carbon double bond carbon, 1 H is here, 1 CH3 is here. Here going to be CH2, continues. Here CH2, CH2, carbon double bond, CH3, H will be here, CH2, and continues. And this is named as, now it's named as cis 1,4 polyisoprene, and that is the natural rubber. So you have seen just now natural rubber having the monomer isoprene and having the polymer as cis 1,4 polyisoprene. Talking about vulcanization of rubber, what does it mean? Let's see. Natural rubber becomes soft at high temperature, okay, and brittle at low temperature. And so to improve its properties, it is heated with sulfur, a mix additive within certain range of temperature. Sulfur forms cross-linked at the reactive site of double bond and the rubber gets stiffened. This simply means that when you have a natural rubber, for example, natural rubber are very soft and they easily get broken when you heat. So this sulfur comes between the double bonds. So let's see how it comes between. Look at the structure for it. And again, this important question they have asked many times in board exams, so keep that in mind. Let's see how the structure will look when you have vulcanization of rubber. So in the place of where there's double bond, there going to be the breaking of the bond and attachment of sulfur. So it's going to be looking like, let's say we have CH2, CH3. We had double bond, now it breaks down to give a single bond. I'm going to show you in a moment. So let's say we initially have something like this with us, okay? Fine. So now what happens is this bond breaks like that way, and they're going to be attachment of sulfur. S stand for sulfur, and that is what you're gonna have for this part. And this is your vulcanization of rubber example. So in exam, when this question comes, write down the whole description as was shown in the picture in this presentation, and then write down this given should I say the structure. We have one synthetic rubber to learn about, that's called neoprene. And I'm sure you have seen this when you saw the example for our elastomers. Now let's see the neoprene monomer structure. The neoprene monomer, neoprene is our polymer. What is the monomer called? It is called chloroprene. And structure, or should I say the IUPAC name is 2-methyl, not methyl this time, it's going to be 2-chloro, buta, 1,3 diene. We had 2-methyl for our natural, but for synthetic we have 2-chloro, okay? So let's imagine the structure, what it would be with the IUPAC name given to us. Since the buta means we have 4 carbon, okay, that's understood immediately. Again, same thing, first and third position has double bond. Let's say other part is, okay, before we do the other part, they say second position chloro, so we have Cl here. So other part would be as it is without being, modified as such. And this is our monomer chloroprene. Now this one, where it undergoes polymerization, unlike our example of our previous one where we talk about writing down 2 monomer of natural polymer, that is basically was our isoprene to get us what we wanted. Here let's just consider one only for the moment, okay? And let's see how it looks. From this you're going to be getting what? You're going to be getting here answer as CH2 single bond, C down Cl double bond, CH single bond, CH2 whole N, and this is our neoprene, and that's it. So this is our example, or this is our one example which must learn for our synthetic rubber, okay? Now first question is, what is biodegradable polymers? So a polymer that can be decomposed by a bacteria. So polymer that can be decomposed by bacteria is called biodegradable polymer. We have 2 examples to learn from, okay? This is a 1 marks definition. It's very simple. It's like you will know what it means, yeah? Just framed in one line. Okay, we have 2 polymers. Number 1 is called poly beta hydroxy butyrate, okay, co-beta hydroxy valerate, VALEARD, PHBV, short form. In exam also, when they ask the structure, they just ask PHBV. They never give you the full name, and they won't ask you also. But I prefer, if you're starting out at the beginning of the year, I always advise you to learn the full name. I learned it. It's very simple. It's polybeta. It's very interesting also, you know, like polybeta hydroxybutyrate, co-beta hydroxy valerate. It sounds very professional. Doesn't sound like professional. So if you have time, you feel so, please learn the full name. But if you think you're towards the end of the year, your exam is coming soon, you're revising now, then I prefer just do PHBV. It has 2 monomer units. So number 1 monomer unit is called 3-hydroxy butanoic acid. Okay, the name suggests it is basically a what? It is basically a combination of alcohol plus carboxylic acid. OIC shows it is a carboxylic acid is there, and hydroxy prefix shows there is also an alcohol present, OH present, yeah. And number 2, so number 1 structure is going to be, see, there would be a different way to write it down, but I won't write it down in a way that I'm able to easily form a bond of the monomer to form a polymer. So I'm going to write this as N-time HO CH CH3 CH2 COH. Okay, now plus number 2, or just another number 2 one is called 3-hydroxy pentanoic acid. So this simply signifies that nothing different, only the difference is that here we have 1 methyl and here is going to be ethyl instead of that. Okay, it's going to be N times HO CH CH2 COH, and here it's going to be ethyl, it's going to be C H2 CH3. Okay, after polymerization, what do we get? So from here, you know, H goes out, OH goes out, giving you water, OH goes, and from here it goes to give me the answer as O CH CH3 CH2 double bond O CH C2H5 was also correct, same thing as that. This 5 CH2 double bond O whole N plus NH2O, and that is our PHBV. Simple, 2 monomers combined together to give you the product. Okay, we have one more last biodegradable polymer, that is called Nylon-2 Nylon-6. Okay, Nylon-2 signify you can have 2 carbons, and Nylon-6 means 6 carbons. So first one we have something called glycine. Glycine, you've heard the name, you have been using also, I suppose. So its structure is CH2 COH on right side and NH2 on left side. So giving you 2 carbons to giving you nylon-2. So remember the N, very important. Let me remove this line, disturbing here, I suppose. Okay, let me have the line this side. Okay, fine. And another one is called amino caproic acid. Fine. Okay, this is NH2 CH2 whole 5 and COH. So we have here 5 carbon, 1 carbon, 6 carbons, and time add a plus sign to signify they're being added together 2 monomers. And let's see what do we get of this one after polymerization. We get N H CH2 carbon double bond O, N H CH2 whole 5 carbon double bond O, then whole N. And these are the 2. So far we have covered what is a biodegradable polymer. Here are covered is first example, that is PBHV. So it's 2 monomers, their structures. Uses of polymers. Yes, as you can see here in this first page I have about 9 to 10 of them. Name of the polymers and the uses, as you can see here, and take a screenshot of this, learn at home by yourself. This is rarely asked if you are around the month of, what should I say, Jan, or around month of Feb. Then don't do this. I prefer you, I advise you. Otherwise, at the beginning, please spend about, let's say, around 10 minutes or 5 minutes whenever you get free time every day, and just like revise it when you're maybe walking on the way or waiting for the bus, and that's how you utilize the time. Okay, this remaining of them is also here. All of them is I've given here, and these are all the polymers which we have done in this chapter and the uses in our real life. Okay, my friends, with this we come to the end of this today's chapter, and I hope this whole, should I say, the chapter course of polymer was helpful for you. I hope you have learned a lot. It was my first attempt to teach you a chapter, so please do check out all my playlists if you haven't seen it yet. Please do check it out so you'll know exactly what I have taught and how it was helpful for you. Please do tell me in the comments down below how much helpful it was for you and what I can improve. And I feel I should make myself a bit more slow, I suppose, at times. And then also let me know, should I make a video about reoptics derivation and about English reading section, how to always get 20 marks all the time, and about Hindi Samas, because I believe when I was in grade 10, Samas was the biggest headache for me, and I know the trick how to always get right for Samas. So I always try to teach those things which I feel I am very, very good at. Like polymers, I was very good as I taught you in the best way I could. And then similarly reoptics, I feel I'm very good at reoptics diagrams and derivatives. So I feel I can do that for you. And similarly, I'm talking about English reading section, especially for grade 12, we have 20 marks. I have always been getting like almost full marks all the time for English reading. So I feel I have the right tools to teach you what to be done. And of course, for Hindi Samas, if you want those videos of any of these, comment down below and I shall be coming up with that video next time. Okay. And then what else? I'm planning to make a video about the best guidebook for grade 10 and 12, especially for board examination. And I do have the many ideas, so I thought to make all those together into one video. So if you want that video also, please let me know in the comments down below. And with this, keep learning, okay? And stay safe, take care. And thank you so much for watching my videos. And please do like, subscribe, comment, okay, to my channel, because I have worked very hard to make this presentation. And if you want the presentation, I shall be posting this presentation in my YouTube channel after I hit about, I suppose, I'm not sure, but I hit about 1,000 plus subscribers. But if you want it before than that, you can always email me in my email ID. I have given the email ID in my link as well. So till then, see you next time, and I shall be making math videos for the school the next week onward, so you can also check that out. Till then, bye bye and see you.